obviously segment PB is 28, and we've already labeled that, okay? So segment PB is 28 because PB is a radius, alright? So pretty simple, and did not mean to do that, and I better ungroup these real quick. There we go. Alright, so 28. Alright, number 12, PE. Well guys, PE is also a radius, so it's going to be 28 also. 13, PD. Now here's where it starts to become a challenge, okay? Please watch. Are you ready? We're trying to find the length of this segment here. Now I have a right triangle right here. Does everybody see that right triangle? However, that right triangle is not going to be helpful because I only know one length. So I can't use Pythagorean Theorem. And also, if I knew an angle, I could use my sine, cosine, or tangent. But I don't know that either. Alright? So, how about this right triangle right here? Look at this. There, there, there. Perfect right triangle. Let's draw it over here so we can see it a little better, okay? There we go. A 28 goes right here. This is ED, which is 21. And this is PD right here. PD. And that's what I'm looking for. We'll call it X. So, Pythagorean's theorem, L squared plus L squared equals hypotenuse squared. So, 28 squared plus 21 squared equals hypotenuse squared. Let me grab my handy dandy calculator here. And let's see what we have here. 28 squared is 784. 21 squared is 441 equals 8 squared. Add those two together and you will get 1,225. And now take the square root of both sides. The square root of 1,225 is 35. And the square root of 8 squared is h. So now I know the length of PD is 35. Alright, 35. So let's put that right here. We're going to probably need that later, okay? So PD is 35. Alright, let's move on now to number 14. We're looking for BD. In fact, actually, I just said we're going to need this probably later. Well, we need it right now because look, we're trying to find the length of BD, right? Well, here's BD right here. Let me get rid of this triangle. Here's BD right here, correct? Well, guys, here's my right triangle I can use. Look at that, perfect right triangle. I know the length of this side and the length of this side. So here's my triangle. This length here is 28. My hypotenuse right here is 35. And I'm looking for this length here, BD. Alright. So Pythagorean's theorem, I have a leg and a hypotenuse. So here we go. Leg squared plus leg squared equals hypotenuse squared. One leg is 28. The other leg is x. And my hypotenuse is 35. 28 squared is going to give us 784.
Why is it put there on the other should be on?
35 squared is going to be 1,225. Alright. Now let's get x squared by itself. Let's bring this over and make it a negative 784. Alright. And if you take 1,225 minus 784, you will get 441. So x squared equals 441. And the square root of 441 is 21. So x equals 21. Okay. So the length of BD right here is 21. And let's check and make sure that's right. Yes, 21. Alright, moving on now to number 15, BC. Alright, now, please look carefully. We're trying to find this segment right here. Okay? Now, if this is a right angle here, then that means this has to be a right angle right here. So we do have a right triangle right there. So my right triangle looks like this, this, and this. Do you see it? So it looks like this, this, and this. Here's your right angle. Now this length right here is BC. That's what we're looking for. This length right here is 21. And this length right here is 75. From D to C. So here we go. We know one leg is 21. We know the other leg is X. And the other leg, or the hypotenuse, excuse me, is 75. So 21 squared is 441. X squared, of course, is X squared. And 75 squared is 5,625. Now bring the 441 over and make it a negative 441. And you will get 5,184. 5,184. Alright. Take the square root of both sides and you will get 72. Alright. So the square root of 5,184 is 72. So the length of BC is 72. And then last but not least, we're going to find the length of PC, which is right here. From P all the way down to C. Well, guys, that's a simple addition problem. From here to here's 28. From here to here is 72. Add those two together, and you will get 100. And so the length of PC is 100. Okay, I really hope that helps. All right, let's continue on here. Okay, guys, looking now at numbers 17 through 22. We're going to find the measure of the arcs. Okay, so here we go. Let's give this a shot. Now, students, listen carefully. All right. C is the center of the circle. Q is the center of the circle. Hopefully, if you've been listening and learning, you know that this arc here is measured by its central angle. So here's the central angle that forms arc CD. If the central angle is 47, then the arc here is also 47 degrees. Okay, so with that in mind, I think it would behoove us greatly, or would be a smart thing, to just label all these angles real quick. For example, when two lines intersect, their vertical angles are congruent. So if this is 47 here, then this is 47 also. Let's go ahead and write that in so we know that. Alright. We also know that a straight line equals 180. So if this angle right here is 47, then this angle right here has to be 133. Okay? Because 133 plus 47 is 180. Now remember, vertical angles are congruent. So if this angle here is 133, then this angle here also has to be 133. So I'm going to write that in also. Okay? Now let's get to work and see what happens. Okay? Number 17. Find the measure of arc AB. Well, here's arc AB. Its central angle is 47 degrees. So arc AB is 47 degrees. BC. Alright, now here's BC from here to here. Okay, now listen, guys. Some of you might say, Mr. Aaron, how do you know it doesn't go from here to here? Because any arc, are you listening? Any arc bigger than half of a circle, you have to use 3 letters to symbolize that arc. And we only have 2 letters. So you know it's the smaller arc, not the bigger arc. Okay? So B, C. Now here's the central angle that forms that arc right there. And that central angle is 133. So the measure of arc BC is 133 degrees. Alright, moving on to number 19. ABD. Now that means, now remember guys, ABD is going to be the bigger arc. So it goes from A to B all the way to D. Well, this is a simple addition problem. This arc is 47. This arc is 133. We know this arc here is 47. So all I have to do is take my 3 arcs and add them together. Okay, so it's really not that difficult at all. So I'm going to take 47 plus 47 plus 133. Did that quickly, see if that's right. Yep, 227. So if you add up all three arcs, you get 227. So the measure of arc ABD is 227 degrees. Now, how about arc BCA? So from B all the way to C, all the way to A. Now guys, please listen and think before you start. Sorry, voice crackage. Before you guys start adding all these arcs together, let's think for a second. If I were to start right here and go all the way to here, that's 360 degrees, right? A complete circle is 360. So really, I'm going from here to here. So the only thing I'm missing is this arc here. So just take 360 minus 47, right? And that would give you 313 degrees. Now, if you want to take 133 plus 47 plus 133, that's fine, and you will get 313 degrees. Okay, but it's faster to just subtract. All right, let's find the measure of arc ADC. So from A to D to C, well, this central angle is 133. So arc AD is 133. So I'm gonna take 133 plus 47. That will give me 180. Okay. Also, another way to do that is AC is obviously a diameter, and a diameter is half a circle. So you know from A to C has to be half a circle, which is 180. But either way is fine, whatever method you want to use. And lastly, arc CD. Well, we already know that's 47 degrees. 47 degrees. Okay. All right. Moving on to the two-word problems. The Jefferson Memorial in Washington, D.C. is a circular building with a rectangular portico, I guess, porch. You're standing 20 meters away from the circular wall of the building, and 49 meters away from the point of tangency. What is the radius? Okay, now, I'm going to help you if you will listen to me carefully, okay? From here to here is 49. Got it? Okay. From here to here is 20. This 20 meters is not the entire thing. Do you understand that? So from here to here we have 20. From here to here we have R. And from here to here is this length here is the same as this length here. So we call them both R. Okay? It's okay to use the same letter because they have the same measurement. This measurement here is a radius. This measurement here is a radius. So we call them both R and R. Okay? Alright. Now, we're solving for R, the radius. We're going to use Pythagorean Theorem, but you have to really, really think back to your Algebra 1 days and let me help you, okay? Now watch. First of all, let's start off with this, shall we? Leg squared plus leg squared equals hypotenuse squared. Okay, now, one of my legs is 49. No problem. Here's your right triangle right here. And here's your right angle here. So here's your two legs. That's a leg and that's a leg. So one leg is 49 and the other leg is R. Now your hypotenuse is a sum. From here to here is 20. From here to here is R. So if you add them together, you get R plus 20. Please do not say that R plus 20 is 20R. 20R is 20 times R. 20 times R is not the same thing as R plus 20. That's like saying 2 plus 5 is the same thing as 2 times 5. And obviously that's not true. Okay? So, R plus 20 is your hypotenuse. From here to here is 20. From here to here is R. Add them together, you get the total length. That should make sense, shouldn't it? Look, if I told you R was an 8, if you knew from here to here is 20, from here to here is 8, you would add the two together and the entire length would be 28, okay? So we have 20 plus R, so my hypotenuse is 20 plus R. Put a parenthesis around it because you're squaring the entire hypotenuse, so you're squaring the whole thing. Now if you will let me help you, I will help you, but you're going to have to listen and not get frustrated, okay? This is not going to be easy, but let me help you. And for those of you that like a challenge, you're going to be challenged, which is good, okay? First of all, let's tackle the easy thing first. 49 squared is simply That means write the 5 how many times? Twice, right? And multiply it. So if I have 20 plus r squared, that means write 20 plus r how many times? Twice. So I wrote it twice. Now, take this 20 and multiply it through the other parentheses twice. 20 times 20, 400. 20 times r, 20r. Got it? Now we're done with that 20. Let's get rid of these lines. If I can't get rid of them. Okay, so I took this 20 and I multiplied it through. I'm done with this. Check it off. Now take your r, multiply it through. 20r times 20 is 20r. R times r is r squared. Now look for like terms. I call this a constant term because it has no letters with it or no variables with it. This is an r squared term. This is an r term and an r term. They're like terms. They're like terms, so you can put those together. So now I have 400 plus 40r plus r squared. So this here equals this here. I know it's a mess, it's a lot of work, but that's what it equals. So now I'm going to put 400 plus 40r plus r squared. Now guys, I know this is a tough problem, but look, it's good to be challenged, and I'm not so sure I'd give you one of these on a test or a quiz, but it's still good for you to do these, okay? Now, it's always good to get your variables on one side because we're solving for r. So see this 400 right here, I'm going to bring it over, make it a negative 400, okay? That leaves me with 2001. Got it? Now I'm going to bring my r squared over here to the other side. When I do it, it becomes a negative r squared, correct? Positive r squared, negative r squared. Look at that, they cancel out. Positive r squared, negative r squared cancels out. I'm just left with 40r. Look at that. Now divide both sides by 40, and you're going to get, let me get out my calculator here. You're going to get 50.025. 50.025. Now if you'll think back to your original problem, all of your measurements were in meters. So the radius is 50.025 meters. Alright, that's your answer. Now, I could have made a mistake somewhere. Hopefully I did not. Let's check our answer. Yep, there it is. We're good. 50.025 meters. Okay. Tough problem. Watch it again if you need to, okay? Number 24. In a poll, 300 people were asked how long they sleep, okay? And it gives you all the statistics. Construct a circle graph for this data. List the percent for each category and the measure of each arc. So let's have some, I'll tell you what, I'm not going to worry about the measure of each arc because we're going to have to find the degrees anyway, so that's just going to be common sense, okay? Let's construct a circle graph using percentages, okay? So my total is 300 people, so people that got 5 hours or less, therefore 18 people said yes, so that's 18 out of 300. If you type that into your calculator, 18 divided by 300, you will get 0.06, which is, move the decimal 2 places, 6%. Okay? I think we'll just leave these in decimals right now. That'll be better instead of percentages. So, 0.06. Alright? We can easily make that percentage later by moving the decimal 2 places. Okay? Next, 48 people needed 6 hours sleep. 48 people, so 6 hours sleep. Personally, for me, I need about 7 hours of sleep is what works for me. Alright, not that you guys care, you probably don't. 48 divided by 300 is 0.16. Alright, there we go. 78 people need 7 hours sleep. So there's my category, 7 hours of sleep. 78 out of 300 people, so 78 divided by 300 is 0.26. Alright. Now, 111 people need 8 hours. So 111 over 300. And that would give you 37. 37.37. And let's see here. 27 people need 9 hours sleep. That would be nice, wouldn't it? 9 hours sleep per night, 27 over 300 would give you 0.09. And then let's do this, let's do this, let's do this, let's do this. All kinds of fun things we can do here. Slide that up. And 18 people got 10 hours sleep or more. That'd be nice. Alright, 18 over 300. 18 divided by 300 is 0.06. Now guys, it's all percentages. It should add up to 100%. So I'm going to quickly just add these up just to make sure I haven't made a mistake somewhere. And I got 100, so we're good. Okay, so there's my decimal equivalents. Now, I'm going to go ahead and draw my circle here. And maybe make it a tad bigger. And now do a good job on your homework, guys. Okay, I know this is kind of tedious, but do a good job, okay? So, I'm going to put a segment here. And I'm going to get rid of my biggest one first. My biggest one is 37. Now, is everyone listening? How do I find the degrees? Well, 0.37 is part of a circle. It's 0.37. Now listen, it's 0.37 of the circle. What does of mean in mathematics? Multiply. So take 0.37 times 360, and that will give you the degrees you need. 133.2. Alright, so I'm just going to say 133 so you can't see right now, but on my computer screen here in my house, I'm holding a protractor up to the computer screen, and I'm looking for 133 degrees, and it's about right there. So let's go with about right there. Now, it does not have to be perfect. It's not a big deal, guys. I'm just sketching the best I can. You don't have to do perfect. I do ask you to be neat. Okay, so they asked us to include the measurements and the percentages, so I'm going to put 133 degrees. Alright, and I'm also going to put what percentage that is. 0.37 is 37%. Got it? Okay. Next, check this off. I'm done with this one here, so we'll just kind of cross that off. The next biggest percent is 26%. Okay, so take next biggest decimal is 0.26. So 0.26 times 360 gives me 93.6 degrees. 93.6. I'm going to put 94. Okay, so if I put I've got to get my protractor again. I know you guys can't see my protractor, but I'm using it here on the computer screen, and I want 90. What did I say? 93.6. So 94 degrees. So let's see. Right here would be 90. There's 5. So about right there is 94 approximately. Okay. So that'll work. That's good enough. So about right there. So there we go. And that's going to be approximately 94 degrees. And we'd also call that 26%. Alright. Okay. Next biggest one would be 16. So I'm going to take 0.16 times 360. And that would give me 57.6. So I'm going to put 58 degrees. 58 degrees. Alright. So here we go again. 58 degrees. Let's see what we have here. We have 10, 20, 30, 40, 50. Sorry guys, your old math teacher's getting old here. Let's see. 10, 20, 30, 40, 50, 60. So we'll back it up to about right there. And that looks pretty good. Alright. So, kind of draw it out to about right there. Alright, and that's going to be 58 degrees. And that's going to be 16%. Alright, and now it's going to get really tough, I'll be honest with you guys. I mean, let's kind of do it like this. And then 22. And that last one should be bigger, so we're going to call that one 32 degrees. So that's good enough, students. We'll just call this 22 degrees, which is 6%. We'll call this one 22 degrees, which is 6%. And we'll call this one 32 degrees, which is 9%. And I'm not going to go through and add all these up and see if they add up to 360 degrees. I mean, we might be off by 1 or 2 because we rounded here and there, but you get the gist of the problem, okay? So if I went too fast, if there's any questions at all, back it up and watch it again. I hope that this video has been a help to you. If you have any questions, don't hesitate.